Academy-MCV4U1-Calculus. The first course is the name of the book that we are using for these series of lessons. It's a book that they use in a couple of universities for bridge courses in Ontario, and it's a book that they use in a couple of provinces in Canada and a couple of states in US. The first chapter is limit and rate of change. The book starts with a little bit of review. The first part of the book in chapter 1 is factoring. Example 1, factor x2 minus 3x minus 18. It's a trinomial with the leading coefficient of 1. We're looking for two numbers with the sum of negative 3 and product of negative 18. Those numbers are negative 6 and 3. Therefore, x2 minus 3x minus 18 is x minus 6 times x plus 3. Some algebraic identities. The difference of squares, a2 minus b2 is a minus b times a plus b. Difference of cubes, a3 minus b3 equals a minus b times a2 plus ab plus b2. a3 plus b3 is a plus b times a2 minus ab plus b2. Sum of cubes. Example 2, factor x3 plus 27. It is 3 to the power of 3 plus x to the power of 3. Therefore, it can be written as x plus 3 times x2 minus 3x plus 9. Factor 2x4 minus 18x2. 2x2 is common factor, so it can be written as 2x2 times x2 minus 9. Then we use the difference of squares, and we write it as 2x2 times x minus 3 times x plus 3. The factor theorem. A polynomial px has x minus b as a factor if and only if pb is 0. For example, we want to factor px equals 2x3 minus 5x2 minus 4x plus 3. By inspection, we see p at negative 1 is 0. Therefore, x plus 1 is a linear factor of p at x. We divide 2x3 minus 5x2 minus 4x plus 3 by x plus 1. The remainder is 0, and the quotient is 2x2 minus 7x plus 3. Therefore, p at x is the multiplication of x plus 1 times 2x2 minus 7x plus 3. Then you divide a by b. If the remainder is r and the quotient is q, a can be written as bq plus r, the division statement. When r is 0, a is b times q. 2x2 minus 7x plus 3 is a trinomial. It can be written as 2x2 minus x minus 6x plus 3. We find two numbers with the sum of negative 7 and product of 6, and we break down the middle term. Then we group them. One group is 2x2 minus x, the other group is minus 6x plus 3. We use common factor, and we have p at x equals x plus 1 times 2x minus 1 times x minus 3. When factoring expressions involved with fractional or negative exponents, we use the law of exponents. For example, 2x3 plus 4x2 minus 6x to the power of negative 1 over 2. The smallest exponents here is x to the power of negative 1 over 2. The common factor is 2 times x to the power of negative 1 over 2. By factoring 2 times x minus 1 over 2, the given expression can be written as 2x to the power of negative 2 times x2 plus 2x minus 3. x2 plus 2x minus 3 is x minus 1 times x plus 3. Therefore, the expression is 2x to the power of minus 1 over 2 times x minus 1 times x plus 3. After talking a little bit about factoring, the book explains a little bit about rationalizing. To rationalize a numerator at the denominator of a fraction contains an expression such as square root of a minus square root of b, we times both the numerator and the denominator by the conjugate radicals. The conjugate of square root of a minus square root of b is square root of a plus b. And if we multiply these two, we get a minus b using the difference of squares. Example, rationalize the numerator of square root of x plus 4 minus 2 over x. The conjugate of square root of x plus 4 minus 2 is square root of x plus 4 plus 2. By times and divide the expression by the conjugate, the numerator is x plus 4 minus 4, the difference of squares. We collect the like terms. We have x over square root of x plus 4 plus 2. Obviously, x shouldn't be 0. In this expression, x is greater or equal to negative 4, but x is not 0. And it can be simplified as 1 over square root of x plus 4 plus 2. The first section of the course is talking a little bit about linear functions and the tangent problem. We know f of x equals m of x plus b is a linear function when m and b are constant. M is called the slope of the line and b is called the y-intercept. If we pick any 2 points on the line, the slope is rise over run. And rise is change in y values, delta y, y2 minus y1, and run is x2 minus x between the points. Since the slope is the ratio of change in y to the ratio of change in x, it can be interpreted as rate of change of y with respect to x. In this diagram, we have a couple of lines. When the slope is 0, the line is horizontal. When the slope is positive, the line is going from the third to the first quadrant, and when the slope is negative, it's from second quadrant to the fourth quadrant. Example 1, find a linear function whose graph passes through the points -1, -1, and 2 and 5. The slope of the line is delta y divided by delta x, which is 5 minus minus 1 divided by 2 minus minus 1, it is 2. The equation of the line is y minus y1 times m times x minus x1. M is the slope. x1 and y1 are the coordinates of one point on the line. We choose 5 and 2. The equation would be y minus 5 equals m 2 times x minus 2, which can be simplified as y equals 2x plus 1. Therefore, the linear function passes through those points is f of x equals 2x plus 1. This is the graph of the line. We have 2 points joining them. We have the graph. The fact that the rate of change of y with respect to x is 2 means that y increases twice as fast as x. Example 2. A linear function is given by y equals 6 minus 5x. If x increases by 2, how does y change? The slope of the line is minus 5. Therefore, the rate of change is minus 5. This means delta y is minus 5 times delta x. That means delta y is minus 5 times 2, minus 10. Therefore, if x increases by 2, y decreases by 10. So far, we talked a little bit about rate of change, and we saw the rate of change of a linear function is the slope of the function. There is an important problem in calculus, the tangent problem. For simple graphs, like a circle, the tangent means the line that is touching the curve at one point. For a little bit complicated graphs, we have to define the word tangent. The tangent line at a point is a line running parallel to the curve and it's touching the curve at only one point. Example 3, find the equation of a tangent line to the parabola y equals x2 at the point 1 and 1. In order to write the equation of the tangent line, we need the slope of the line. To find the slope of the tangent line at 1 and 1, we call it P. We pick a point Q on the curve with the x coordinate of x and y coordinate of y. We write the equation of the line passing through P and Q. To write the equation of the line, we need the slope of the line. The slope of the line is delta y over delta x, which is y minus 1 divided by x minus 1. Therefore, the slope of the tangent line, the secant line passing these 2 points is x2 minus 1 over x minus 1. Since x is not 1, we can reduce it to x plus 1. Now, we find the slope of PQ by choosing some values for x. If x is 2, the slope is 3. X is 1.5, the slope is 2.5. When x is 1.001, the slope is 2.01, when x is greater than 1. When x is smaller than 1, we choose 0.9, 0.99, and we see the slope. As you see, whether x approaches to 1, that means whether x is getting close to 1, when x is bigger than 1, or when x is smaller than 1, the slope is going to be near 2. The closer q is to p, the closer x is to 1, and the closer slope is to 2. This is a concept in math that we discuss in this chapter. It's called limit. This process is shown by limit of x2 minus 1 over x minus 1 as x approaches 1 equals to 2. And we say slope of the tangent line is the limit of slope of the secant line as Q moves towards P. By knowing the slope of the tangent line equals 2, the equation of the tangent line would be y minus 1 equals 2 times x minus 1, which is y equals 2x minus 1. Let's recap. We started with some concepts that we need in calculus. We talked about difference of cubes, sum and difference of cubes, sum of cubes, and difference of squares. We talked about factor theorem. We talked about the rate of change of a linear function. We saw the slope of the line is rate of change of the function. And we introduced the tangent problem. We informally used the meaning of limit to find the slope of the tangent line. Our next lesson is the limit of a function.